Okay, guys, so today we're gonna be working backwards. What do I mean by that? So I'm actually gonna be giving you the equation of your linear function, and then I'll ask you to sketch a graph using the equation. And sketching a graph of a linear function is fairly simple. I'm going to show you some tricks. So there's something, in English we call this a sketch, which, just gives you a rough idea of what the graph will look like. But graphing is like when you're being a little bit more precise, okay? In most cases, sketching is, sufficient. Okay, you don't have to be super precise. In math, you just have to draw a sketch just to get an idea of what the graph looks like, and you can get away with that, right? But I'll show you how to graph as well. But before we proceed, I'm gonna ask you to do this starter question. Now, this one might throw some of you off, so I'm gonna ask you to pause the video. So this is question 9. I only asked you to do up till question 8 on your homework. I intentionally did not give you 9 and 10. So try this out. So like I said, this might throw you off, and that's normal. And then well, I'm gonna continue and hopefully help you with this. So again, you have 2 points, right? You're looking for the equation in slope-intercept form. So that's the form where y is equals to mx plus b. And the problem over here is, so I'm going to call these my 2's, these will be my 1's, right? So slope is just equals to the change in y divided by the change in x, which is equals to y2 minus y1 over x2 minus x1, okay? So my y2 is 5, right, from here. And my y1 is also 5, so from here. So 5 minus 5, that's 0, and then 3 minus 2. So this will just be 0 divided by 5, but whenever you divide, whenever your numerator is 0, um, doesn't matter what you're dividing it by, your end result will be 0. Okay, so your slope is 0. Okay, so because your slope is 0, that means your function y is equals to mx plus b, right? This is 0, so 0 times x is 0, so this disappears. So that means, right, and it disappears because remember your slope is 0, so 0 times x is just 0. Okay, 0 just annihilates everything that it multiplies, right? So that's why this disappears. So that means your function will just be y is equals to b, okay? Now, you need to figure out what the b value is, and you can't really use algebra to figure out what b is, but you'll have to kind of like, whenever your slope is 0, okay, the trick is your b value will always be your y coordinate. And as you can see, it's the same everywhere, okay? And I will just quickly draw a sketch to tell you why. The equation of this line is y is equals to 5, okay? Now, if I were to plot those points, okay, so this is my x-axis, this is my y-axis, I'm going to plot the point minus 2, 5. Okay, minus 2, 5 is over here. And now I'm going to plot the point 3, 5, which is there, right? Now, if I connect these 2 points, as you can see, my function is constant. Okay, what do I mean by constant? By that, I mean this function, right, continues, doesn't have to stop. It doesn't matter what my x value is. Over here, my x value might be, oops, over here, let's say, my x value might be 1. Over here it might be 2. But it doesn't matter what my x value is. My y value is always 5. Okay. And the reason why this is constant is because my slope, m, is equals to 0. Remember your slope, right? Your slope tells you how quickly your function is rising, right? Um, but here your function is not rising, which is why your slope is 0. So your slope kind of is important because it will help you graph your function, okay? So this is the rule, y is equals to 5, because this tells me that it doesn't matter what my x value is. My x value could be like, let's say, minus a million, okay, or something. Let's just say minus 10 because, just because it just minus million would be way out here, right? Way out over here. So it doesn't matter what your x value is. So even if it's minus 10, your y value will still be 5. Okay, so this is what it means. This is what you mean by a constant function. Okay, it's always taking the same y value regardless of your x value, essentially. Okay, so again, key thing over here is understanding that your slope is 0, and the slope is what will actually help us, the slope and y-intercept. Okay, so these two things will actually help us sketch and graph linear functions. Okay, so how do we do that? So recall, right, any linear function can be represented by the following equation. As you've seen in the starter question, right, the most crucial piece of information for graphing purposes is the slope, okay? So when your slope is positive, what do I mean by positive? Remember, your slope is m, okay? So positive means when m is greater than 0, okay? When m is positive, when your slope is positive, your function will always rise, okay? So your y value, your y-intercept, right, could either be positive. So in this case, it's positive, right? Your y value here is positive. But because your slope is positive, your linear function can either do two things, okay? You're gonna start from here. It can either go up, right? So it can either rise or it could go down, okay? But when your slope is positive, your function rises, okay? So if your slope is positive, this is what your function will look like, something like this. It doesn't matter what your b value is, right? Your b value could be 0. Your function will still rise. Some of them might rise more rapidly, like the second one. Maybe let me use a different color. So the second one over here, um, rises more rapidly, but it's still rising, okay? And the third one, let's say over here, slope is positive, so it's still gonna rise, maybe a little, you know, slowly, but it's still rising, okay? So positive slope means, so I guess conclusion is positive slope means your will function will rise, okay? What do I mean by rise? Mathematically, rise means as your x values are getting bigger and bigger, right? As your x values are getting bigger and bigger, your y values are also getting bigger and bigger, right? So here, let's say x is equal to 2, right? And let's say maybe y was equal to, let's say, I don't know, 3 or something, right? Now here, as you can see, x is equals to 4. My y value is also getting bigger, okay? It's probably like, I don't know, like maybe 10 or something, okay? So rising means your function is kind of like going upwards, okay? So function will rise when your slope is positive. Right, some of you probably already guessed, right? When your slope is negative, it will have so that means your m is less than 0, right? It's negative. So this, when your slope is negative, your function will fall, okay? Or not rise, okay? So however you want to call it, let's say function will decrease is the word that they use, decrease, but I'm not going to get into that. Okay, so here your function is increasing, rise. So, if you want, this is increasing. Okay, so that means your y values are increasing when your x values are increasing. Fall, by that I mean it's decreasing. Okay, so that means as your x values are getting bigger, your y values are getting smaller. Okay, so decreasing. Okay, and an example of that would be again, right? So if I have this is my graph. Actually, you know what? I'm going to do this a little differently. Um, yeah, so I think that maybe looks a little better. So different colors. So this is again, you kind of have to start at the y-intercept, okay? And you have two options, either to go up or to go down. Actually, there's three. One of the last case is when you remain constant, right? When you're not changing. But usually it's either going up or down. But because my slope is negative, right? Your function will go down, so it will decrease. Okay. Some of the functions might decrease more rapidly than the other ones, right? So the more negative your slope is, the faster it will decrease. So let's say this one over here, okay, my b value is negative, but because my slope is negative, I don't have a choice. I have to go down. But maybe, this one goes down a little slowly than the green function. It's supposed to be a straight line, so that doesn't look like a straight line to me. And it's kind of hard to draw on an iPad. Okay, so let's just say something like this. Okay, so and you know what? Let me just make this like this. So it's still decreasing, but very slowly, okay? So when your slope is negative, your function will fall, okay? It will decrease. Now, zero slope means when your slope is equals to zero, as you saw in the starter question. When this happens, then you have a constant function, okay? Constant function. So y will just equals to b, right? Y will always be a constant, okay? The y value doesn't change um, despite your x values. Okay, so your x values could be changing, but your y will be a constant. What do I mean by a constant function? So this is x, right? This is y. A constant function is kind of like a flat line. Okay, so this would be a constant function with a positive b value, right? And this would be a constant function with a negative b value, right? So as you can see, your y values don't change, okay? Now we're going to use this fact to quickly sketch and also graph linear functions, okay? So graphing linear functions is not too difficult. So for example, if I were to graph this function, okay, I'm going to have to focus on two things. First, it will be my slope, right? So I know that m is equals to 2. So this is positive, right? So that means my function will rise, okay? And I know that b is equals to -4, and you can kind of use that as your starting point, okay? So if I were to quickly sketch this, I'm just going to do this. This is my x, this is my y. I'm going to start at -4. So my y value is -4 over here, right? -4. And because my slope is positive, right? So maybe let me write the -4 a little better. So 4, and then let's put the minus afterwards, right? Because my slope is positive, right? It's 2. My function has to increase. So it's probably going to look something like that. Okay, so that's what we call a sketch. But we can make the sketch look more precise. How can you make the sketch look more precise? You need 2 points to to I guess sketch or graph a unique linear function. How do you find the second point? Just plug in an x value. Okay. Uh, One trick that I'm going to tell you is you can pick any x value. It doesn't really matter, right? So in this case, if I pick x is equals to 2, right? If I plug in x is equals to 2, then 2 times 2 will give me 4, and 4 minus 4 will give me 0. So this is the point. This is my point 0, comma. This is the point where my x value is 0 and my y value is -4. Now, if I plug in x is equals to 4 in my function, right? If I plug in x is equals to 4 here, I'm going to get 0 back. So once you have 2 points, you can quickly just join the 2 points, and then you'll have a precise looking function, and then you can kind of like scale this however you want, right? So in this case, maybe a good way of scaling this would be to call this 2 and this 2, right? So that means this has to be -2. So this kind of makes sense. But see, a graph is more precise because you will have all the scalings and everything done for you. Okay, so how do you find a good x value, right? That's the question. How did I find that, how did I know that 2 would be a good x value? One of the best ways of doing it is so this is your equation, right? So y is equals to 2x minus 4. One of the best ways of doing this question is you always have to look at the denominator of your coefficient. Okay, the coefficient of x, just look at its denominator. This guy has denominator 1, so um, any multiple of 1 would be a good candidate. So if you pick x is equals to 1, that's a good point. If you pick x is equals to 1, then your y value, right? If x is equals to 1, then y will equals to 2 times 1 minus 4. So this is -2. So at 1, your function will be at -2. Actually, hold on. I think I made a mistake, right? This point over here should be 2, right? When x is equals to 2, my function is at 0, so I'm gonna have to scale this a little differently. So this has to be 1. Yeah, so now this makes more sense. Okay, so when x is equals to 2, right, my y value is 0. 2 times 2 is 4, not 4. So that means scaling this would be 1 then. So this would be -1. Okay, so yeah, so your denominator kind of tells you how to scale your x's. Okay, so in this case, the denominator is not really given to you. If it's not given to you, it has to be 1. Okay, so if this was just 2x, the denominator was 1. So a good way of scaling your x-axis would be to just look at the denominator, and a good way to scale your y-axis would be to look at the numerator. Okay, that's one trick that usually works. So scale your y-axis by looking at your so this tells you the scaling of your y-axis. Again, you could go with 1 1, that also works. I'm just kind of like showing you a trick. Okay, so the numerator shows you how to scale your y. Okay, and this denominator shows you how to scale your x. Okay, so let's just practice with a few more questions. Okay, so again, now I have to graph this function. So remember, my equation has to look like y is equals to mx plus b. I don't have a b over here. Okay, so this means that my slope is equals to -5. So that means my function will decrease, right? It will fall. My b value, it's not there, so that means it's 0, right? Because it's +0. But when you have +0, you don't have to write that, right? Because it's just redundant information. So what you would have to do is just, draw your Cartesian plane, right? This is x, this is y. I'm going to start at this point 0, right? My y value is 0. And then because my slope is negative, my graph will decrease. And that is it. Okay, so again, you can scale this if you want, right? So um, this is -5/1. So that means I can scale my graph, this way. So if this is 1, this is 2. So this is 1, right? If you plug in x is equals to 1 in this function, so 5 times -1 is -5. So that means your y value, this is my y value. This has to be -5. And at 2, I'm going to be at -10, right? So this is -10, okay? So something like that. And now you see, using these points that you can generate by plugging in x values strategically in this equation, you will have a much preciser sketch, which is what we call a graph. Okay. How would you sketch this one? So again, remember, y is equals to mx plus b, right? So when I compare this function to this tells me that my slope is 0, right? When my slope is 0, this means that I have a constant function, right? So something like this, constant function. My b value is equal to 7, so this one's the easiest one to graph. And the scaling doesn't really matter here. Okay, so my b is 7, right? And then it doesn't change. Okay, so and you can scale this however you want. So you can call this 1 and then 2. So this obviously has to be 7. So this, if you want, is -7, right? So that's how you would graph the function. Now the next one is tricky, right? Because now you have a oops,